Welcome back to our system design series. Today we are going to explore graph databases, a unique and powerful type of database that's designed to understand and store relationships between data points. So, graph databases are becoming increasingly popular for use cases like social networks, recommendation engines, and fraud detections because they can efficiently model complex interconnected data. Okay, so you can handle them efficiently. Okay, so what is a graph database? A graph database is a type of database that use graph structures to represent and store data. In a graph database, data is represented as nodes and edges. Nodes represent entities like people, products, or places, while edges represent the relationships between these entities. This structure makes graph databases incredibly effective at finding connection and patterns within data that would be cumbersome to manage in traditional relational database. So let's try to take an example. So let's think about a structure of having a user. Okay, let's say that we have a user. We have multiple users. What is this? No. Let's say that we have different users. Okay. So think of like a social network or as an example, and each user is in the network is a node, and the connections between these users, because we said that a GraphQL has nodes and edges, so the edges are or the connections, it will be like a friendships or follows or whatever it will be represents the relationships between them. So let's say that user, let's say that this is user 1 and this is user 2 and this is user 3. So user 1 follows user 2 and user 2 follows user 3 and user 3 follows both. Let's say that. And let's give user each one a different color, and let's put like that and put this in different color as well, so it will be easier for us to see what's going on here. Okay, so as I said, um, while we have users and we have for example the nodes represent like the nodes represent the users, and the connections and the edges are like friendships, follows, or friends or OBE. So user 1 follows user 2 follows user 3, and user 3 follow both of them. In a graph database, querying relationships between users is highly effective or and efficient. You can quickly answer the question like, who are my friends of friends? For example, the user 1 is a friend with user 2, and user 1 is following user 2, but user 1 doesn't follow user 3. User 1 can know who's actually the followers of my followers. Like he can go that deep. And this way, by this way, like both user 1 and user 2 could answer this question, because the relationships are stored directly without the need for complex, let's make it for complex join. If you are familiar with relational databases, you will understand the join operations that are often required in relational database and how it can get pretty slow, specifically if we have multiple joins. So one of the key features in graph databases is their ability to perform traversal querying efficiently and effectively. A traversal query involves navigating from one node to another across the edges. In relational databases, this might require multiple joins operations, which can become slow as the number of tables and relationships increases. In a graph databases or in graph database, these connections are explicitly defined, making traversal queries fast and efficient, even with large datasets. These are several. There are several popular graph databases available today. I guess there is Neptune, one of the most famous one. Each of these databases offers features that making working with complex relationships straightforward and performative. Yeah. So let's try to understand or talk about what are the common example use cases for GraphQL databases that you will likely use them in your system design interview. The first thing will be social media networks. Social network, okay. Okay, so as mentioned earlier, graph databases are perfect for modeling social relationships. They can be used to analyze connections between users, to find mutual friends, and even suggest new connections based on shared interests or existing relationships. The ability to handle dynamic and evolving relationships makes graph databases ideal for social media platforms. The second thing will be the recommendation engine. Recommendation. Oh, it's a pretty recommendation. It's a pretty wrong word, to be honest. And engine, let's put the A for the engine. So, graph databases are also widely used in recommendation engine systems. For instance, an e-commerce site might use graph database to recommend products by analyzing the relationships between users, products, and user behaviors like purchase or views. By traversing the graph, it's easy to find patterns that can lead to highly personalized recommendation. Number three is fraud detection. Detection. Let's put the D only. Detection. Um, in financial sector, detecting fraud often involves analyzing relationships between different accounts and transactions. Graph databases make it easy to identify suspicious patterns such as an account being part of larger network of potential fraudulent transactions. By modeling these connections as a graph, it's possible to quickly identify unusual cluster or anomalies. And lastly is knowledge graphs. Like combines like Google companies like Google use graph databases to power knowledge graphs, which represent information about entities and their relationships. This allows for more intelligent search results and answers to questions that require an understanding of how different concepts relate to one another. So it looks as a pretty good one. But there is something like, despite their advantages, graph databases also come with some challenges. One key is the scalability. One of the main problem, scalability. Let's put it like that. Okay, so while graph databases excel at handling complex relationships, distributing a graph across multiple servers can be more difficult compared to other types of databases. However, many modern graph databases have made progress in offering distributed capabilities to handle larger dataset. Another challenge is the learning curve because it's really complex. Like if you are coming from a background in SQL and relational database, learning how to work with graph databases and their query languages such as Cypher for new 4G uh, can be quite tough. Not a fun way also, because however the effort is often worth it for application where understanding the relationships is key, providing the value, but it's really important thing. So that's it for this video. If you like my content, subscribe and hit the notification bell so you never miss a video. And if you have any questions regarding the databases, graph databases, or anything you think, just put it in the comment section below. So that's it for this video, and see you in the future.